ground starts shaking in many different ways. The houses that are not sturdy enough may collapse, causing great losses. I am Architect Kiki. Do you know how to build houses at different locations? This is a seismic hazard map. The colors and numbers marked on the map indicates different levels of earthquake resistance required in house building. Wherever it is, houses should be sturdy. Can you place the buildings at the matching zones of seismic fortification intensity? Level 9 Fortification Zone. Level 8 Fortification Zone. Level 7 Fortification Zone. Level 6 Fortification Zone. Now let's build the sturdy houses to stay safe even when earthquake strikes. School building. The government has increased the seismic fortification criteria. Now we need to strengthen the school building's earthquake-resistant capability. Let's set up the temporary fencing for the construction site first. Safety is the priority in the construction site. Place the safety signs here. Turn the knob to move the aerial work platform up. The steel frame is a bit rusty. Polish it with sandpaper. Spray paint the steel frame so that it won't rust so easily. When an earthquake strikes, the damper on the energy dissipation device can deform to dissipate or absorb the seismic energy, thus efficiently prevent the collapsing of the building. The school building is reinforced. Great! Buildings with seismic strengthening and buildings without seismic strengthening will act differently in an earthquake. Slide the button to check it out. Small earthquake. Stay intact in a small earthquake. Medium earthquake. Repairable damages in medium earthquake. Big earthquake. Won't collapse in a big earthquake. Great job! Wow! The earthquake-resistant building you built is so sturdy! Amazing! Keep going! Mall. Here are some bent rebar. Use this machine to straighten the rebar first. Let's make a core tube shear wall first. The core tube shear wall is in the center of the building. It is built of reinforced concrete instead of bricks. The shear wall structure can resist lateral forces and has strong earthquake-resistant capability. Pour the concrete onto the floor slab. Spread the concrete even. The floor is done. It looks nice. The mall still lacks shiny signboards. Wow, it's such a gorgeous mall! Good job! Buildings with seismic small earthquake. Stay intact in a small earthquake. Medium earthquake. Repairable damages in medium earthquake. Big earthquake. Won't collapse in a big earthquake. Great job! Wow! The earthquake-resistant building you built is so sturdy! Amazing! Keep going! Mall. Bridge. We're going to build a bridge here. However, the underwater foundation is very soft. We must reinforce it first. The foundation soil is soft underwater. Pierce the pile foundation through the soft soil into the bedrock to make it sturdy. Thus, the pier will stand in the water sturdily. Now we need to install seismic isolating bearings in between the piers and the deck. Now let's build the deck. Connect the deck and the columns with wire cable so that the bridge will be sturdier. The bridge is built! What a pretty bridge! Is the bridge we built sturdy enough during earthquake? Let's check it out by swiping the button. Small earthquake. Stay intact in a small earthquake. Medium earthquake. Repairable damages in medium earthquake. Big earthquake. Won't collapse in a big earthquake. Great job! Wow! The earthquake-resistant building you built is so sturdy! Amazing! Keep going! Hospital building! The old building is in danger of collapsing. Let's dismantle it first. Set up the bearing base plate. Pour cement onto the steel reinforcement cage to make sturdy pile foundation. Time to install the seismic isolation bearings. Make sure all the screws are tightened. The foundation is built. These soft and flexible rubber seismic isolation bearings work to isolate the house from the ground. When an earthquake strikes, the isolation bearings deform to isolate the house from the shaking of the ground and keep the house much safer. Select a hospital building. Wow, the hospital is built! Oh, We also need to build a helipad. With a helipad, helicopters will be able to send patients to the hospital faster. Earthquake-resistant buildings and normal buildings will act differently in an earthquake. Slide the button to check it out. Small earthquake. Stay intact in a small earthquake. Medium earthquake. Repairable damages in medium earthquake. Big earthquake. Won't collapse in a big earthquake. Great job! Wow! The earthquake-resistant building you built is so sturdy! Amazing! Keep going! Can you place the buildings at the matching zones of seismic fortification intensity? Level 9 Fortification Zone. Level 8 Fortification Zone. Level 7 Fortification Zone. Level 6 Fortification Zone. Now let's build the sturdy houses to stay safe even when earthquake strikes. Villa. Let's build the brick wall first. Scrape off the excess cement. Bind the rebar columns with rebar rings. Fix it in place with steel wire. Let's fix the mold. Fill the steel reinforcement cage with concrete to make a sturdy constructional column. The steel reinforcement cage of the beam and the steel reinforcement cage of the column must be connected when building each floor. Next, pour in the concrete to make a sturdy ring beam constructional column. Thus, the houses are sturdier and more earthquake resistant. Pick a roof you like. Then pick the color to paint the wall. buildings with ring beam structural columns and buildings without ring beam structural columns will act differently in an earthquake. Slide the button to check it out. Small earthquake. Stay intact in a small earthquake. Medium earthquake. Repairable damages in medium earthquake. Big earthquake. Won't collapse in a big earthquake. Great job! Wow! The earthquake-resistant building you built is so sturdy! Amazing! Keep going!